So in this problem, we're told that we have a constant pressure calorimeter, which is a coffee cup calorimeter, and we're told that we add 60 mils of 0.300 molar barium hydroxide to 60 mils of 0.600 molar hydrochloric acid. The reaction causes the temperature of the solution to rise from 22.58 degrees Celsius to 26.67 degrees Celsius. So we know this is an exothermic reaction because the temperature of the solution is going up. The water in the solution is absorbing the heat that was given off by the reaction. If the solution has the same density and specific heat as water, what is the delta H for this reaction per mole of water produced? And volume is not necessarily additive, but we're going to assume that volume is additive in this case. And we're also going to assume that the density of the solution is 1 gram per milliliter to make things easier. The solution is going to be mostly made out of water, so this is an okay approximation. So the very first thing that I want to do is I want to calculate the heat that the water absorbed, the water in the solution. And I do that through Q equals mc delta T. So the mass of the water multiplied by the specific heat capacity of the water times the delta T. We're told to assume that the density of the solution is that of pure water, which is 1 gram per milliliter, which means that 1 gram is equal to 1 milliliter. So if I have 60 mils added to 60 mils, I have 60 grams for 60 grams. So my total mass is 120.0 grams. Here's the specific heat capacity of water. And the delta T is the final temperature minus the initial temperature to give us 4.09 degrees Celsius. When I multiply these three values together, all of the units cancel out except for the units of joules, my energy unit. This is a positive number because the water is absorbing the heat. Now notice I'm not worried about significant figures here. If I were, my final answer should have 3 significant figures, and I'll remember that for my final answer. But if I start rounding too early in the process, then my rounding errors, my rounding can cause my final answer not to be exactly correct. So I'm not going to round until the very last step. Now remember, we want to find out delta H per mole of water produced. So we now know how much heat was produced. The next step is to figure out how many moles of water were actually produced. So in this chemical reaction, we're adding a base, barium hydroxide, to hydrochloric acid. And we know that when a hydroxide base reacts with an acid, we're going to form water and a salt. So barium has 2 hydroxides. It has a charge of +2, so 2 hydroxides are needed. With 2 hydroxides, 2 protons are needed, and 2 waters will form. And then we also form barium chloride. So we see this as a balanced chemical equation. So before we can figure out how much water is produced, we have to have a balanced chemical equation. So we know for each mole of barium hydroxide, I'll get 2 moles of water, and for 2 moles of hydrochloric acid, I'll get 2 moles of water. So my hydrochloric acid and water ratio is 1 to 1. To figure out how many moles of barium hydroxide and how many moles of hydrochloric acid I have, I use the formula molarity times liter is equal to number of moles. So I change my volume of 60 milliliters to liters, and 0.0600 liters times 0.300 mole per liter, and my liters cancel out, give me 0.018 moles of barium hydroxide. I do the same for my hydrochloric acid, and I get 0.036 moles of hydrochloric acid. So looking at the amounts that I am given, I see that I have exactly twice as many moles of hydrochloric acid as I do barium hydroxide. This is important because it means I don't have a limiting reactant. Now, because this is a 1-to-1 mole ratio of hydrochloric acid to water, once I know how many moles of hydrochloric acid have reacted, then I know how many moles of water have formed. And right here, I'm just going to show you the mole ratio calculation. If I have 0.036 moles of hydrochloric acid, according to the balanced chemical equation, 2 moles of water are formed for every 2 moles of hydrochloric acid that react. So that means 0.036 moles of water are produced. And then now I know how many moles of water are produced, and I know how how much heat the water absorbed. This is how much heat the water absorbed. We already calculated that. And remember, this was a positive value. The water was absorbing that heat. So the reaction actually has the opposite sign. The water absorbed the heat. The reaction gave off the heat. So I need to be careful to include my sign here, because my Q of my water in the solution that absorbed the heat is equal and opposite in sign to the heat that was given off by the reaction. So here's the heat that was given off by the reaction. I'm going to change this to kilojoules just because my problem asks for kilojoules. So I move my decimal point 3 places to the left to get kilojoules. And looks like I kind of made a mistake here. I don't think these numbers are actually right. But anyway, so 0.036 moles of water, I divide that into it, and then I'm going to round my final answer to 3 significant figures. Back when we calculated our heat, we only had 3 significant figures there, and actually when I was calculating my number of moles, there were only 3 significant figures in my value as well. I should put a 0 at the end there to show that there's 3 significant figures. All right, so don't forget your negative sign for the reaction. This is an exothermic reaction, and I hope this helps.